Hello there and welcome. Whether you're a curious 10-year-old just starting to wonder about the stars or a lifelong learner with a real passion for history, I am so incredibly glad you've joined me for this explainer today. We're going to take a grand, chronological field trip through time. We are going to open up the ultimate storybook, the story of our entire universe, starting from the very beginning all the way down to the formation of the beautiful planet we call home. So get comfortable, because it's going to be a really joyful, fascinating ride. Okay, let's just dive right into this. To really understand the history of our universe, we need to think big. I mean, really, really big. The universe is about 13.8 billion years old. Now, that is a number so huge, it's honestly kind of hard for our brains to even picture it. So let's use a fun little trick called the cosmic calendar. Imagine we pack all 13.8 billion years into just one single calendar year. In this setup, the universe begins on January 1st at exactly midnight. And everything happening right now, us having this conversation, that maps to the very final second of December 31st, just before midnight. It really puts into perspective how vast time is, and how super recent our own history truly is, doesn't it? So, how exactly did our cosmic January 1st actually begin? Well, 13.8 billion years ago, absolutely everything we know, all the energy, all the matter, even space itself, was packed tightly into a single, incredibly hot, dense point. And then, in a phenomenal event we call the Big Bang, it rapidly started expanding outwards. Now, here's the cool part. It wasn't an explosion in space, it was actually an explosion of space itself. And as it expanded, the whole universe began to cool down, setting the stage for literally everything else that was to come.
Chapter 1. The Ultimate Beginning. Forces of Nature.
Right after that initial spark, the universe wasn't just getting bigger, it was actually writing the fundamental rules of nature from scratch. In the earliest, tiniest fractions of a cosmic second, everything was defined by incredibly powerful forces. As the universe cooled down a bit, these forces separated into the four fundamental rules that govern our entire reality today. We've got gravity, which pulls things together, the strong force, which holds the center of atoms super tight, electromagnetism giving us light and magnets, and the weak force, which is responsible for things like radioactive decay. Those four invisible hands really started shaping the cosmic clay.
Let's just pause and trace how this grand story unfolds over time. We kick off with the Big Bang, 13.8 billion years ago. But think about this next massive milestone. Our sun doesn't even begin to form until about 4.6 billion years ago. That means for over 9 billion years, which is most of our cosmic calendar, our solar system didn't even exist yet. Countless generations of stars lived and died long before our little neighborhood even began to take shape.
Which brings us to Chapter 2. First stars light up. The cosmic forges.
Now those first stars, they were absolutely crucial to our story. You see, the early universe was pretty simple. It only had basic, lightweight elements like hydrogen, helium, and just a tiny sprinkle of lithium. There was literally nothing to build a rocky planet out of, let alone a human being. But eventually, dark, lumpy clouds of gas started pulling together through gravity. As they got denser and denser, their centers got so incredibly hot that nuclear fusion ignited. These were the very first stars, and they were absolute giants, like 30 to 300 times more massive than our sun. Deep inside their fiery bellies, these massive stars acted as cosmic forges, creating the heavier elements we'd eventually need, like silicon, iron, and magnesium. And when those giant stars finally exploded as supernovas, they beautifully scattered those essential building blocks all across space.
Chapter 3. Birth of our solar system. A swirling disk of dust.
All right, fast forward with me to cosmic September, about 4.6 billion years ago. Picture a swirling, collapsing cloud of gas and dust, left over from those exploded older stars we just talked about. Most of that material was drawn right to the center, igniting to form our wonderful sun. But there was a whole disk of leftover debris just swirling around it. As the sun flared to life, it created this powerful solar wind. And this wind literally blew the lighter gases, like hydrogen and helium, far, far away into the outer, colder edges of the solar system. Which is exactly why we have massive gas and ice giants like Jupiter and Neptune way out there. But the heavier rocky materials, the metals and silicates, they stayed close to the warmth of the sun, solidifying to form the rocky planets, including our future home.
Chapter 4. A Very Messy Earth. The Hadean Eon.
If you could hop in a time machine and travel back 4.6 billion years, you wouldn't even recognize our home. Early Earth was basically a hot, messy teenager. It was constantly being heated from the inside by radioactive decay and from the outside by endless space collisions. The entire surface was just a glowing, shifting ocean of molten lava.
Active volcanoes were spewing gases everywhere, creating a really thick atmosphere filled with hydrogen sulfide, methane, and up to 200 times more carbon dioxide than we have today. Oh, and there was absolutely zero breathable oxygen. So yeah, not exactly the best spot for a summer vacation.
And just to make matters a bit more chaotic, the early Earth went through this wild phase called the Late Heavy Bombardment. I actually like to think of this as cosmic popcorn. Our young solar system was still full of flying debris, and Earth was just relentlessly pelted by asteroids and comets. They were popping off everywhere across the surface. But there's a really beautiful silver lining to this violent shower. Because the Earth was so hot, any initial water it had would have just evaporated away. So scientists believe these impacting comets, flying in from the freezing outer edges of the solar system, likely acted as little cosmic delivery trucks, bringing us the very first oceans of water.
Chapter 5. The Great Moon Crash. The Giant Impact Hypothesis. Sometime around the start of this messy Hadean eon, a massive object, we're talking roughly the size of the planet Mars, came hurtling toward our very vulnerable young Earth. Traveling at an absolutely incredible speed, it delivered a massive, glancing blow. It didn't hit us dead on, but it completely grazed the side of our planet. This catastrophic collision knocked a colossal amount of molten rock and debris right up into orbit around the Earth. And over time, gravity beautifully molded all that swirling, chaotic debris into the peaceful sphere we now know as our moon.
You know, when you look at a beautiful, glowing full moon tonight, you are actually reading a history book. Have you ever noticed those large, dark patches on its surface? For the longest time, people wondered what on earth they were. Well, thanks to the Apollo astronauts bringing back lunar rocks, we now know those dark areas are ancient scars. During its own violent teen years, about 3 billion years ago, the moon experienced heavy impacts that cracked its crust, allowing dark, molten magma from deep inside to ooze right up and fill those basins. So those dark spots, they're actually giant, frozen lakes of ancient lava.
Chapter 6. Settling Down for Life. A Stabilized Climate.
Now, here is the really amazing twist. That seemingly violent, destructive moon crash, it actually ended up saving Earth. The newly formed moon gave us some absolutely incredible gifts. Its gravity acted like a brake, slowing down Earth's really dizzying rotation. The impact also gently tilted Earth on its axis, which, by the way, is the exact reason we get to enjoy our beautiful changing seasons like spring and autumn today. And maybe most importantly, the moon acts as a steady anchor in the sky, stopping our planet from wobbling unpredictably. This stabilization finally allowed Earth's wild, chaotic climate to find a long-term balance.
With a newly stable climate, the Earth could finally take a deep breath and calm down. The fiery, molten surface cooled and hardened into a solid crust. The water delivered by those cosmic popcorn comets began to pool and collect, forming our very first vast oceans. And it was right there, in that warm, nutrient-rich water around 3.8 billion years ago, that the very first tiny chemical building blocks of life finally emerged. Our messy teenager planet had grown up into a nurturing, life-giving home.
And well, that brings us to the end of our grand field trip for today. Just take a second to think about it. We started as a tiny, unimaginably hot speck of expanding energy. And through fundamental forces, giant star forges, and cosmic collisions, we arrived at this beautiful, living blue marble. We've mapped out billions of years together, but, the story is still being written every single day. So I want to leave you with this one thought. As we stand here in the final seconds of our cosmic calendar year, what do you think the next cosmic year is going to bring for us? Thank you so much for exploring this incredible cosmic storybook with me today. Keep looking up and always keep wondering.